You are welcome to the GMAT 41's past questions review class. As we are all aware, we are in exam season, our students getting ready to take their semester exam, other set of students getting ready to sit for JAM, and of course, others preparing to take their WhatsApp. It's only natural for these students to get prepared, in order to go into the examination hall and make sure they do their best, attempting questions in order to come out with excellent results. That's everyone's wish. That is why, as you already know, the GMAT 41 is always there to give you the best. I remain Engineer Omaka, and here we're about to kickstart past question reviews in order to attempt to see how we can answer certain questions that may have been conducted by different exam bodies in the past. Of course, this is invaluable to your preparation, okay? If this is the first time of visiting the GMAT 41's YouTube channel, I urge you to please subscribe. Turn on the notification bell so that once we upload any new video, alright, you will be personally notified in order to follow up with what we're doing. As a reminder, just like it goes in all walks of life, the foundation of whatever we do is very important. And therefore, as we move on into this past question review, if you're having challenge in any area of sciences and engineering, because you can always feel free to contact us in order to get access to our full range of learning classes on Telegram. And if you're in Oka, Anambra State, remember you can always join our class. Contact us to know the physical venue of our class. We shall be starting a review of Unit 6 past question because we've got the student preparing for their semester examination. I'll be looking at Math 102, Elementary Mathematics 2. It focuses more on aspects of calculus. And here we go with our very first question. If y equal to minus squared sine x minus cos 2x, then find dy dx. The options we have as shown on the board. Now this is a differentiation problem, and so we are simply asked to find dy dx, this differential coefficient with respect to x. The problem given to us, the function is y equal to negative squared sine x, and then minus cos 2x. This is the same as minus sine x all raised to the power 2. That's the interpretation of squared sine x. And then minus cos 2x. Please, like I stated earlier, if you have challenges with any foundation, as for what we're going to do here, because I'll be using certain terms that can help to facilitate solving this problem. Remember, this is an objective exam. Are you following right? So you have to be as fast as possible. So if you've got any challenge, please feel free to contact the GMAT 41. The number showing on this screen, you can use it to contact us either on WhatsApp or by call. Is that okay? And then you can get access to our Telegram channel for full range of learning as the basis of what we're going to do on the board here. Is that okay? Now, here we've got this question. I refer to this as the major function of this 2 here, the power. And of course, this function, f of x, that is sine x, as the minor function. And by differentiation, a direct interpretation to chain rule, all we've got to do is to do our major minor differentiation, and then we can get the result for here. We will also differentiate base in that way and also get the result. So how do we approach differentiating this squared sine x by the major minor function? We're going to use this 2 to multiply this sine x. So that's going to give us negative 2 sine x. Is that okay? Negative 2 sine x. And then we are going to differentiate this f of x, which is this sine x, because it's a function of x. For differentiating it, we're going to get cos x. Is that okay? Negative, come to this term, and then differentiate cos 2x. How do we go about that? I'm going to differentiate 2x, and as well differentiate the major function, which is cos in that case. If I differentiate these 2x, I'm going to get 2. Differentiate cos is going to give us what? Minus sine. minus sine what? Sine of these 2x in front of these cars. We've differentiated this. I've decided not to talk about let u be equal to anything, chain rule. We are not going to use that. We don't need it. An objective case as the case might be. Is that okay? Can actually go straight by using what I call the major minor differentiation concepts. And then this is going to give us negative 2 sine x cos x. Then this is going to give us plus 2 sine 2x. Alright? Now, at this point, we are done with resolving this. This is actually our dy dx. But unfortunately, if you look at the answer we got here, it's not here in the option. And therefore, you have to think of how to simplify this further to see if it can give you any of these results. And clearly, look at the options we have here. All of them are sine 2x, alright? And so I'm going to work this thing towards getting sine 2x. And how do I do that? Interestingly, I'm going to show you something. You see this term? These are 2 sine x cos x. It has a value. This 2 sine x cos x from trigonometric identity is equal to sine 2x. And therefore here I'm simply going to put that 2 sine x cos x is equal to what? Sine 2x. So this becomes minus sine 2x. I hope you're following, right? That's what this term is in trig identity. And then we're going to add this 2 sine 2x to it. And so you see that we're not getting sine 2x and this term also sine 2x. The difference is that this is negative 1 of sine 2x and this is what? Positive 2 of sine 2x. They are like terms because both of them contain sine 2x. And therefore we can add them up. If we add up this eventually is going to give us something like 2 sine 2x minus sine 2x. Therefore, our dy dx for this question is simply going to give us sine 2x. And this is the answer. So what's the correct option as given to us here? Option D is the answer. And this takes us to our next question. And the next question reads, find the equation of the straight line which passes through the point minus 2, 1 and is parallel to the line y minus 3x equal to 2. We've got the options on the board as usual. This problem is extracted from coordinate geometry and we are required to find the equation of the straight line that passed through the point minus 2, 1. There is something very significant about this line whose equation we are to determine. We were told that this straight line is parallel to another straight line that has this equation. And so we can start from there. First, from here we are told that the line passed through the point. Let's say x1, y1 is equal to minus 2, 1, alright? Which means that x1 is equal to minus 2, y1 is equal to 1. Where this line, whose equation we are trying to determine, passed through. Now, this same straight line, whose equation we are looking for, is parallel to this one. So what does that mean? For two lines to be parallel, it means they have the same gradient, the same slope. And we use n to represent the slope, which is the coefficient of x in this equation. Alright, we're given y minus 3x equal to 2. And so what we're going to do, we would move the 3x, minus 3x to the right hand side to make y subject of the formula. The reason is because the equation of a straight line generally will have y equal to mx plus c. This is the standard. And then this n is the gradient. Okay, so we need to get the gradient in this case. So this is y equal to 3x plus 2. If this negative 3x crosses, it becomes positive on the right hand side. So what does this tell us? Clearly, we've got this to be our gradient. N is equal to 3. So this is the slope. This is the gradient of the new line whose equation we are required to get here. You see how we've obtained the gradient from this equation? Is that okay? Because we are told that this new line whose equation we have to determine is parallel to this. Therefore, that line and this one will have the same gradient. Our problem is solved. Once we know the gradient of a line and we know the point where that line passed through, we are as good as done solving that problem. All we have to do is to recall the equation of the straight line given as y minus y1 equal to n open bracket x minus x1. That's the equation of a straight line. Now from the question we know x1 and y1 already, and we've gotten the value of our gradient n. So we can just simply substitute. Alright, so I've substituted for y1 and x1 as well as for the gradient. We now have to simplify this. This is going to give us y minus 1 equal to, if you open up this bracket, this is going to give us x plus 2 in the bracket. And then this 3 will now open this external bracket to give us 3 times x, which is 3x, and then 3 times plus 2, which will give us plus 6. Good. Now we are done solving this problem. We've gotten the equation per se, but we have this minus 1 and this plus 6. They are like terms, so they need to come together. Now before I proceed to do any other thing, I am going to look at these options given to us so that we know how to handle that problem. Now if you look at these options given to us, everything was made equal to 0 from option A to D. Option A is none of the above, okay? Not that. And so I'm going to move everything from here to the left. Is that okay? Doing that, I'll have y, 3x will cross to give us minus 3x, plus 6 will cross. If this plus 6 crosses to the left, we are going to have minus 1 minus 6 because they are like terms. And that will give us minus 7. Everything will now be equal to what? 0. And there our answer is there smiling at us. Okay, so what's the correct option? Looking at the options provided, y minus 3x minus 7 equal to 0. Option B is correct. We are moving on to the next question, number 3. Find the equation of a straight line which passes through the point minus 2, 3 and is perpendicular to the line y minus 2x equal to 4. We've got the option here on the bar, and so we're going to solve and select what the correct answer to this question is. We are required once again to find the equation of what? A straight line. Now, what are the significant things about this line? Number 1 is that the line passed through the point minus 2, 3. So we know x1, y1. And then secondly, we are told that the line is perpendicular to this other line. And therefore, we can get the gradient of the line whose equation we are looking for. We can get its gradient, its slope from this one. But again, watch out. We're told that the line whose equation we are looking for is perpendicular to this one, not parallel, like the previous question we solved. So when it's perpendicular, let's find out what we do to get the gradient. Once again, I'm going to start by bringing out the value of our x1, y1 as given to us in the question, minus 2, 3. And then we're given the line y minus 2x equal to 4. I'll standardize it. Y is equal to 2x plus 4. And so looking at this, we see clearly that our gradient m is equal to 2. That is the gradient of this line. Are you following right? The gradient of this line is plus 2. The line whose equation we are asked to find is perpendicular to this line that has this gradient. Therefore, for us to get the gradient of our own perpendicular line now, we use the relationship. Recall, m1 times m2. I can use this, or I can simply say m times m perpendicular. This symbol I'm using it to represent m perpendicular is equal to minus 1. And this is the relationship between the gradient of a given line and the gradient of another line that is perpendicular to it. So just imagine I have this straight line, and then this one is perpendicular to it. Okay? So if the equation of this line is given, now if I get a gradient as m, then this one, its gradient will now be what? M perpendicular. I can call the gradient of this one m1, this will become m2. Or I can choose to call the gradient of this straight line m, then this second straight line that is perpendicular to it, I will call it m perpendicular, and we've decided to use this symbol for it. Good. Having said, let's get to business. I'm going to substitute. Clearly you see that m perpendicular will be equal to negative 1 divided by what? M. And that will be negative 1 all over 2. Because we got the gradient of this line to be equal to 2. Look at that. Now we've obtained the gradient of our own what? Perpendicular line, whose equation we are looking for. We can now write the equation of a perpendicular line. And good enough, it is still similar to the one we saw previously. They are both equations of straight line. The only difference is that in this case, we will no longer use n, which is 2, but we'll use n perpendicular, which is negative 1 over 2. So we're going to open bracket x minus x1 and then substitute. Let's do that. Y minus 3 equal to negative 1 over 2, open bracket x minus x1 is minus 2. And then we shall simplify this term, okay? Going to be fast in doing that. To simplify, I will cross multiply in order to clear this fraction, then use minus 1 to open this bracket. That is what I want to do. Like I stated earlier, if you're having challenges, okay, with the foundation of this, or with mathematics in general, or even other aspects of sciences and engineering related courses, you can contact the GMAT 41 and numbers always available on WhatsApp or by call, okay? You can also join our public Telegram channel to contact us from there. The link to the public Telegram channel is below this video lesson, okay? So you can just go click on it. You can contact us from there as well too. Now we are moving on. If I clear this fraction, this is going to be 2y minus 6. I'm using this 2 to multiply this term here. Then that will be equal to negative 1 will multiply this term. Take note that negative here is plus already. So what we have in this bracket will be x plus 2. And then minus 1 is opening it up, giving us minus x. And then minus 2. Correct. All I have to do now is collect every term to the left hand side, because from the option here, everything was made equal to 0. And so this is going to give us 2y. If minus x crosses, it becomes plus x. If minus 2 crosses to meet this minus 6, the minus 2 becomes plus here. And so we shall have minus 6 plus 2, which is minus 4, equal to 0. And we are done solving this. Let's go back to the options and see which one is the correct option. So we've got option C, 2y plus x minus 4 equal to 0. Option C is the correct answer. We shall move on to our next question, number 4. And the next question reads, the endpoints of the diameter of a circle are minus 4, 0 and 4, 0. Find the equation of the circle. Now this problem is conic section related as well as coordinate geometry related. There's something about circle anyway, but all the same, let's just focus on what we are asked to find. We are to find the equation of the circle. In this question, we're given the diameter of the circle. They give us the coordinate of the endpoint of the circle. As you can see on the board, minus 4, 0 and then 4, 0. And you know something, once you know the diameter of a circle, you can easily get the radius, right? I know why I've just mentioned radius. Because in getting the equation of the circle, we actually need the radius of the circle. Now you can imagine a circle, or just take a look at this circle on the board, okay? And then you see the diameter. The diameter is a straight line drawn which passes through the center of a circle, touching 2 points on that circle. Is that okay? And so we have the coordinates as you're seeing there on the screen. Of course, minus 4, 0 and 4, 0 as given in the question. Now, in determining the equation of a circle, there are 2 different equations, which of course they are the same anyway, but if you look at them, different as you're looking at them, but we use one to derive the other. The first one is called the general equation of a circle, x squared plus y squared plus 2gx plus 2fy plus c equal to 0. And the second one, we'll call it the standard equation of a circle, x minus a in bracket all squared plus y minus b in bracket all squared equal to r, where r is the radius of the circle. So we can use any one of the 2 to solve this problem. Is that okay? Like in the first one, the g and x there are used to obtain the center of the circle, where the center of the circle is simply minus g, minus f. That is the coordinate of the center of the circle. And then in the second case, you're talking about the standard equation of the circle. The center is simply a, b. But we don't use minus there. The minus you see in the formula is a fulcrum minus, that's how I call it. Anyway, I think I've said much about this. For foundational knowledge of circle and its equation, you can actually contact us to join our Telegram channel for full range of learning. Let's get back to business. I've told you what I'm going to use in solving the question. Now we are given these coordinates. I will call it x1, y1, and that is equal to minus 4 comma 0. All right, and then we're also given x2 comma y2, and this one is equal to 4 comma 0. And I told you that I'll be using the standard equation of circle x minus a raised to power 2 plus y minus b raised to power 2 equal to square root of r, where r is the radius. So with this equation we have here on the board, we are going to determine the value of a and b, which are the center of the circle. And of course, we are going to determine our radius. To get the center of the circle is simple. You can still take a look at the circle we have there. The center is simply half of the diameter. So we can get the coordinate of the center. And since the diameter is a straight line, and you are talking about getting the coordinate of the center, this now takes us to full coordinate geometry, where we can use the midpoint formula to determine the coordinate of the midpoint. So let us do that. In this case, we can say that our a comma b, which represent the center, is simply, in the midpoint formula, this is what we are going to do. Simply add the value of x1 plus x2 divided by 2. Then add the value of y1 plus y2 and divide it by 2. You get the coordinate of the center. That is what I am going to do here. So going by that, our a comma b is going to give us x1 from the question is minus 4. Because if you do this, you get 0 comma 0 as the center anyway. But let's just still solve. Minus 4 plus x2 is 4 divided by 2. And then this one is 0 plus 0 divided by 2. If you work on this, you would get 0 comma 0 as the value of the coordinate of the center a comma b. So this is telling us that a is equal to 0 and b is equal to what? 0. We have achieved the milestone because we've been able to get a and what? B. We're now going to look at getting r. How do we get r? R is the radius, which is simply half of diameter. So what we're going to do is to determine the magnitude, the value of the diameter using the coordinates. Then whatever we get, we'll divide it by 2 to get our radius, right? So that's just a trick there. And now how do we get the value, the magnitude of the diameter? Once again, take a look at our circle and you will see that the diameter is just a straight line. It has 2 points with the coordinates given, minus 4 comma 0 and then 4 comma 0. Do you remember that we have what we call the distance between 2 point formula? So if you have 2 points, that length, the distance, we can determine the magnitude. And what is the formula for calculating the distance between 2 points? As in our diameter here, d, which is the diameter, is simply square root of, we've got x2 minus x1, and then you square it, plus y2 minus y1, and then you square it. This is the distance between 2 point formula. So for our diameter, this is just what we use, where the diameter is the distance between the 2 coordinate points given. Substituting here, we've got square root, and so minus minus will give us plus, and then we have 8 squared. 8 squared is 64, square root of that 64 is 8. So that is our diameter, therefore the radius will be equal to d over 2, which is 8 over 2. Our radius is 4. Our problem is solved. Come back to this standard equation of circle and then fix it up. There we have x minus a. Our a is what? 0. Square it. Waste of time putting that 0, plus y minus b is 0. Another waste of time putting that 0 anyway. Then we're going to equate it to the square of the radius, and the radius is 4. So I'm going to square it. Is that okay? Simplifying this and then collecting this 4 squared to come to the left hand side, we are going to get x squared plus y squared minus 16. Then that will be equal to 0. And of course, we've gotten our answer. Okay? So let us go to the options provided and see which one is x squared plus y squared minus 16 equal to 0. Option C. And that's the correct answer. We are moving on to the next question, number 5. The 5th question reads, evaluate integral square x ln x dx. Now this problem is an integration problem. We are to integrate, okay, x squared ln x dx. So we're going to be fast in dealing with this. But if you look at this, this term is a product of 2 different functions, okay? We have x squared, which is a polynomial, and then ln x, which is logarithmic function. Both of them are being multiplied. When exposed to a problem like this, what do you do? Now, if you observe this, differentiating this x squared, you cannot get ln x. And if you differentiate in x, you can't get x squared. Therefore, we're going to use integration by parts. And what is our integration by part? The formula simply tells us if you're given integral u dv to evaluate, the answer is equal to u times v minus integral v du. And so I'm going to do that swiftly on the board here. Question given to us to evaluate is integral squared x ln x dx. And now from here, we can decide to select our u and of course our dv. And just to say that here, we have our u to be equal to ln x, and then our dv is equal to x squared dx. Is that okay? Solving this directly, integral of squared x ln x dx is equal to, remember the formula? You can say that on the board, uv minus integral v du. And so what is our u here? Our u is ln x. So it's going to be ln x times v. Our v is obtained from integrating this term, which we call dv. If you integrate x squared here, you are going to get x raised to the power 3 divided by 3. That helps to give us what? The value of v from dv. And so this is times x raised to the power 3 divided by 3 minus integral v du. We know our v already, which is x cubed over 3 times du. Du is simply to differentiate that term which we call u. And u here is in x. If we differentiate in x, we are going to get 1 over x. And simply because this still has integral sign, I'm going to multiply this by dx. And so this is going to give us, if you multiply the x by x raised to the power 3 divided by 3, we are going to get x raised to the power 3 over 3 ln x. Then minus, please let's take a look at this and see what is going to happen to the term inside this integral sign. This x will cancel one of the x from this x cubed, so this is going to become x squared. And then from here you have x squared, alright, times 1 all over 3. This 1 over 3 is a constant, and so it's going to come out of the integral sign. Are you following? So we've got 1 over 3 integral x squared dx. And now we are left integrating this x squared. Just integral of x squared is a simple and straightforward term to get. Once you know your standard integral, your problem is solved. And the integral is simply x raised to the power 3 all over 3. And so working this out, this is equal to x cubed over 3 ln x, and then minus 1 over 3. Like I said, if you integrate this x raised to the power 2, you're going to get x raised to the power 3 divided by 3. So x cubed over 3. We are done integrating, so we shall put plus what? C. If you take a look at this term, you'll see clearly that something is common to this and this. I've obtained my result. This is the integral result. Are you following? And so any other thing I do from here will be guided by the options that I have here. If you look at this term and this term, x raised to the power 3 divided by 3 is common to both. So we can factorize x cubed over 3. Okay? And then open bracket. If you pull out x cubed over 3 from this term, to know what to be left in this bracket is simply to use this x raised to the power 3 over 3 to divide each of the terms where you brought it out from. So if you use this x cubed over 3 to divide this term, ln x will be left. Put a minus. Use x cubed over 3 to divide this term. 1 over 3 will be left. Then we're going to put plus c. Good. We'll simplify this, and that is simply the integral of this term, x squared ln x, using integration by part. So let us take a look at our options and see the one that is equal to what we've obtained. X raised to the power 3, and then in the bracket we have an x minus 1 over 3, then plus c. The correct option is option B. Remember, our c is a constant of integration. In our next class, we are going to proceed, okay, to deal with further past questions from this elementary mathematics 2, Math 102. Remember to subscribe and follow us so that once I upload any new content, alright, you will know what is happening from GMAT 41. Don't forget to turn on the notification bell, because only by that you will be personally notified once you upload other past questions. Stay with us, share our videos, like and comment, and of course invite other scholars, your friends, your colleagues to subscribe and follow us as we guide you.